Hey, Spice Ads, it's Emily with Spiceworks. Thanks for tuning in today and joining us on another Spiceworks Partner webinar. Three critical storage capabilities for modern virtual infrastructure, brought to you by Pivot 3. Before we get started, I want to remind everyone this webinar is being recorded. If you have to step away for any reason, you will get an email with a link to the video in about a week. Also, there's a Q&A box on your screen to the left, and I encourage you to submit your questions at any time during the presentation. If we're not able to get to your question live, someone will be able to follow up with you offline. As usual, we also have a live chat, so join in by clicking the brown widget at the bottom of your screen. Now let's get started. Today's presenter is George Wagner, Senior Product Marketing Manager. So George, whenever you're ready, take it away.
Okay, great. Thanks a lot, Emily. And thank you, everyone, for joining me today. My name is George Wagner, and today's presentation is 3 critical storage capabilities for enabling your modern virtual infrastructure. Quite a mouthful, but very important information we're going to go through today. I think of these 3 critical capabilities, you may be familiar with maybe 2 of them, but I believe the third one is definitely a newer topic that you're going to be hearing much more about. Not only in storage, but also in hyper-converged infrastructure, et cetera. So before I get started, a little bit about me. So I started my career in IT. I was an IT manager for many years and moved from there into the product side with vendors as an SE, as a product manager in product marketing, and this is where I am today. With that, let's just jump right into it because I want to be mindful of your time. And first kind of wanted to set it up with a couple of the challenges that are facing storage when it comes to virtualization. And this may not be a shocker to pretty much everyone on the call today, but if you've ever attended a VMUG, which I've had the pleasure of attending multiple, there was a troubleshooting storage performance for virtualization breakout sessions. They still do, in fact. This slide is actually from a couple of years ago. But the topic, the very first slide of that entire presentation was this one, right? Storage, where bad things happen. And they went on to say that the biggest reason why people call into VMware support is due to ultimately performance issues from storage. And we're seeing less and less of that, of course, now with the adoption of solid-state storage and solid-state arrays and hybrid arrays. Becoming more and more prevalent out there, but there are ways that this is definitely still an issue today. In fact, I had the pleasure of talking with some analysts late last year, and I'll share with you some of the comments they had to me around flash storage infrastructure in particular. But so knowing this, kind of where bad things happen, we know it's storage. It's definitely a nightmare. It is getting a little better. There's things like vVols, which with VMware released last year, virtual volumes, and VMware vSphere 6. And so that's definitely helping things. And we'll touch on that here in just a little bit. So what are the challenges, the pressing challenges facing storage administrators, IT administrators, virtualization administrators? Once again, no surprise. Right, managing data growth, according to IDC, managing data growth, it's exploding, and meeting performance requirements is definitely important. Meeting availability requirements, recoverability, if that's even a word, requirements as well. So all these are extremely important. And on top of that, while data needs are increasing, we have more sophisticated applications, ways to virtualize. Some folks are going to virtualize their desktops and VDI deployments. The one thing that's always true here is that end user expectations are growing exponentially. Okay, expectations exponentially. There we go. Everyone wants what they want, and they want it right now. People's appetite for latency is definitely much lower than it used to be. They want it immediately, and as time goes on, that trend will continue. So how can things get much faster than they already are with Flash, right? Well, there are still some considerations out there that you need to keep in mind when you continue deploying. If you've already done, maybe you're 75% there on your server virtualization. Maybe you're looking to do VDI, for example. You're looking to virtualize those mission-critical applications that you've had running on standalone servers for fear that they wouldn't get the appropriate amount of performance due to resource contention. Those are things we all think about. So when we look at the storage, the key considerations that I'll be talking about, tongue twister, we're talking about performance, right? Predictability, which is something that many of you may not have been hearing a lot of talk about, but you probably will start to, as well as management, right? The first and the last one are things that we've all been dealing with forever. Right? From a performance standpoint, all flash and hybrid arrays, questions that should be asked when considering all flash is this array actually designed for flash, or is it essentially a rip and replace of hard drives, essentially plugging those right into disk controllers, which gives you some fantastic performance, by the way, and low latency, but it's not optimized for flash, so you're not getting the most out of those devices. Also, there are many types of flash out there, and we'll talk about that in just a moment. Secondly, from a predictability standpoint, especially when it comes to virtualization, is predictable outcomes. Are you able to prioritize what applications matter most? It probably sounds cliche, but not all applications are created equal. I know in my case, I had certain applications that if they were offline, even for a few moments, I would get screams. If there was latency, even this was 10 plus years ago, latency would cause phone calls. So there are certain applications that need to have priority over performance, and that's what I'm talking about here. So am I able to prioritize my application workloads? Am I able to meet my service level agreements, whether they're implicitly set or explicitly set? I had to sign something saying that I'm going to meet these. So predictable. And that's very important. We talk about virtualization, mixed workloads, especially with the I/O blender, et cetera, so it can get quite hairy. And finally, management. With features, with a lot of the vendors, including ourselves, and I'll talk a little about who we are in a moment, but taking and incorporating converging management of solutions into VM or vCenter, for example, it's making things a lot easier. Features like vVols, being able to surface features into vVols using the VASA 2.0 provider, items like quality of service and data protection, et cetera. So making things a lot easier from an administration standpoint, allowing customers to reduce their operating expenses and ultimately just save money and be the hero. So these are the key considerations, and I'm going to kind of go through each one of those in just a moment. But first off, I wanted to tell you a little bit about kind of who we are and the product that I'll be talking about today. So my name is George Wagner. Once again, I'm doing the product marketing for Pivot 3. Pivot 3 specializes in smarter infrastructure technologies in the form of flash storage, PCIe Flash storage to be exact, as well as hyper-converged architecture, which we'll be talking about on other webinars. From a flash storage perspective, this system, the N5 that Pivot 3 has been on the market for about 5 years now, and really excels in the areas of ultra-low latency performance because we design the systems around PCIe Flash, which I'll go into in a little more detail here in just a moment, and kind of the benefits behind that. But more importantly, we built it on a foundation of quality of service. So we have a quality of service engine, of quite sophisticated one, to be precise, and it allows you to set targets, to prioritize, to do active real-time data movement between tiers in order to hit SLAs, and of course management, right? It's a no-brainer. You've got to have a way to simply manage it. Not only manage it from as a storage admin, but also it needs to be easy enough for generalists, virtualization administrators, app administrators to provision both capacity and performance. So when we talk about performance here, it's not just as simple as adding solid state to storage arrays, right? I think if you close your eyes and you think to yourself, what is an SSD? Typically, SSDs people think of them as The image that conjures up is a 2.5-inch drive with NAND flash inside of it, right, plugged into a disk controller, plugged into a PCIe slot, and go, real fast. But there are some considerations to take into account. First off, storage bottlenecks still exist in flash arrays. This is true. This is when I was kind of going back to what I said earlier. We got to present, in fact, to ESG back in November, and I was talking about our new all-flash arrays that we were going to be launching at the time. Brian Garrett, in fact, was talking to me, and he said that, he'd been testing all-flash arrays in their systems, and after I've mentioned that, we've been seeing, we've understood from customers and from testing that there is, in fact, latency in these all-flash arrays. He completely agreed, and he'd been seeing up to like a second of latency, in fact, so it was pretty remarkable, and it really has nothing to do with the NAND, the flash itself. It has to do with the packaging around it. So the array, CPU, bus bandwidth, dedupe compression algorithms, SAS controllers, network connections, etc. So they still exist. There needs to be a way to manage that. Also, flash is more than just SSDs, right? There's PCIe, there's dual-ported SAS. There's higher endurance from anywhere from a third of drive write per day to 25 drive writes per day, up to 1 million IOPS. Different form factors. So, and each of these have advantages over the other, right? So if you're thinking about if you need the ultimate and low latency, you're going to look at perhaps PCIe, for example, or NVMe, which essentially is PCIe with a host controller interface that's optimized for flash. But you got to choose the right tool for the job. I shouldn't even have this one in here, but I'll go ahead and say it anyway, right? Apple, in the last year or so, have actually taken and replaced SSD with PCIe Flash. So PCIe is what we've done in our systems today. They've seen up to, I think it's like 6 times faster. There it is, 6 times faster than their standard SSDs. And the real reason why this is because you're removing the bottleneck. If you think about disk controllers. Disk controllers were designed, these ones, in fact, the ones you have in your servers and laptops today were designed probably 20, 25, 30 years ago for disk drives. Okay, and they're only able to handle 6 gig throughput on them, and you plug these SSDs into them, which are able to handle much more. After you add 1 or 2 of these things, they become a bottleneck, right? So you're taking what is essentially memory and treating it like a disk drive. You're sending seek commands and other types of read-write commands to it when in fact it doesn't even behave like a disk drive. And this basically limits the performance you're ever going to get out of those SSDs. And albeit it's still fast, very low latency, you're not getting the true performance out of it. On the PCIe Flash side, so PCIe Flash is essentially taking those same NAND chips and they're on the actual PCIe card and plugged directly into the bus itself, bypassing the controller altogether. So extremely low latency, 4 times the performance as far as reads are concerned, 10x on writes, 5 times the throughput. You're talking 40 gigs throughput on PCIe 2. So much faster, higher endurance at times, right? That's becoming less and less the case, right? High endurance, that was a huge difference between PCIe Flash that we use in our systems, which was Fusion IO, versus the typical SSDs. But you still see, now you're starting to see much higher endurance on the SSD side as well. But overall, for concentrated, high performance, low latency workloads, PCIe is definitely the way to go with these, right? You simply can add more by adding more into the PCIe bus. You don't worry about bottlenecking one controller. So what we've done on our Pivot 3 and 5 arrays that we're talking about today is essentially, rather than using the conventional array recipe of taking and plugging in SSDs into a disk controller, what we've done is we said, okay, let's make our fastest tier RAM, right? So we use RAM as a tier. It's a multi-tier architecture. RAM is a tier for the extremely low latency reads if you need to have like bursty quick reads. But for our second tier, it's PCIe Flash, and our systems can handle up to 4 PCIe cards in a single system. It can be up to 15 terabytes, in fact, of just PCIe Flash. And then on the back end, we populate the systems, the arrays, with either hard drives, which are a hybrid device, or with SSDs, which are an all-flash array. So it's a multi-tier all-flash array, multi-tier hybrid array. And then on top of that, we layer on our quality of service, which I'll talk about in just a few minutes, that enables that predictable performance and efficient resource utilization as well. So having a flash array, as I mentioned, it's definitely great. You're definitely going to get much more performance than you would out of any traditional disk array. I mean, I forget what the manufacturer was, but I even had a NAS, old NAS boxes. This was probably 15 years ago, and they had, who made it? Fireball. Was it Quantum, I think? I mean, they had, these were called Fireball drives, but in all actuality, they were, 5,400 RPM drives, completely bottlenecked. In fact, you basically use it for filing, or for storing files only, which is, a file server. But now with Flash, you're starting to see, latencies decrease, but we're still seeing latencies, and we still understand that there is a difference in the data you have in your system. If you really step back and think about a SAN, right, and what you're using it for, it's typically to consolidate multiple workloads, right? Database, perhaps email if you're not using hosted email already, order databases, web databases, ERP if you're not going to the cloud for that, files, etc. But although you want them to all be available, some definitely are more important than others. So you look at this IDG, kind of going back to research that's been done based on this IDG report. 75% say that data changes constantly over time. What's important right now may not be important tomorrow, and that 5% of that is constantly a moving target. And then to take a look at the other set of information there, 94% of professionals think that, yeah, we should be able to manage our data. I want to manage my data performance, but unfortunately only about 32% are doing it. And a lot of those are doing that by taking and siloing data, right, creating multiple silos, a silo of maybe an array of all flash, an array of disk drives, maybe a hybrid. So it's not very efficiently, as far as how they're doing it. What we've done at Pivot 3 is we designed the system. As I mentioned, we designed the system around quality of service. We spent our time back in the 2009 or 2010, 2011 time frame, really designing a unique quality of service that now is in fact patented. We have a patented quality of service engine. In fact, it was the first QoS engine for primary storage, a patent awarded by the U.S. government. So it's very unique in that respect, and it provides 3 major benefits. The first is the ability to target workloads with performance using pre-configured policies. So a lot of P's in there. So we have pre-configured policies. I'll show those to you in just a moment. They're very simple. They're pre-configured. They essentially set performance minimums. So instead of having, I'm sure you've heard other vendors say they have quality of service, but for the most part, they're maximums. So they're telling you how much you can have and you can't have any more. Well, what if you need that performance? What if we turn that around and said, okay, there's a minimum amount of performance that will allow you to get. You'll get more than that, but then we prioritize it and say, okay, now beyond that, there are certain applications that during resource contention periods get the lion's share of the I/O, of the throughput, and that's what we're doing. So we do that through prioritization, so prioritizing resources to meet SLAs, and I'll explain how that works in a moment. And finally, automated data placement. This is not to be confused with tiering. What we're doing is we're taking as I showed you a moment ago with the architecture, there are multiple tiers, if you will, inside of the system, And what quality of service does, we have what's called dynamic data placement that moves data between the tiers real time in order to meet your application SLAs. And in fact, that now applies to virtual machines as well, VMs with vVols, which we'll go into in just a moment. As I said, these are very simple policies. There are 5 today. There'll be more down the road. In fact, I'll go ahead and hint to it right now. There'll be more by the end of the year. But of the 2 systems that we have, the all-flash array and the hybrid array, they're both rated at a pretty hefty IOPS rating, 450,000 IOPS on the all-flash, 250,000 on the hybrid. And remember that hybrid array, while it does have disks in it, it can have up to about 15.6, I believe, terabytes of PCIe Flash in it as well. And so what happens is, as you provision your volumes, because this is an iSCSI system, 10 gig iSCSI, as you provision your volumes, you provision capacity, give it a name, and you assign a performance policy to it, a QoS level. And that QoS level defines its minimum performance levels in terms of IOPS, in terms of throughput, and then its maximum latency. So these are maximum latency numbers, and then the minimum IOPS and throughput. So there are 5, and as you can see on the right sides, I have what are called service levels. So this essentially defines the priority given for performance resources to your workloads under resource contention. So resource contention is essentially defined as multiple workloads in the case of storage, trying to access your flash, for example, or your RAM cache. In this case, we guarantee that these SLAs, that your minimum performance levels for policy 1 will be met for any volume, VM, vVol that's assigned to that policy. We'll do our best effort to meet the SLAs of business critical, and then on non-critical, they're nice to hit, but we're not guaranteeing they're going to be hit, that you're going to hit those SLAs. We're going to give you the performance, those minimum performance levels as much as we can. We'll provide those and enable those as much as we can. But our goal here is to make sure that you can prioritize what matters most to your business and then meet the SLAs that are associated with those. And they're just quick, there's simple policies, and I'll show those to you in just a moment. So why do we do this? Well, if you look at storage without quality of service, for example, on the left side of the screen, all data is treated the same. So if you have a single pool of storage, right, and you have a non-critical workload, in this case a development database that spikes in performance, it spikes in its resource allocation within the storage system. Your more mission-critical workloads, like your order database or a power user or VDI user, those are impacted. So you get inconsistent performance levels. And so even in the case of a hybrid or all-flash array, you went ahead and made this investment in this newer architecture with flash, but you're not getting the most out of it. In the case of our quality of service, you set those policies and they're defined as, once again, your SLAs of mission-critical, business, and non-critical. Now when you have that same thing happen, you go ahead and do some intelligent throttling on the development database to ensure that the SLAs are met for order database and for the power user. That being said, though, if, let's say, the order database needed more performance, we'll go ahead and throttle back. First, we'll throttle back that non-critical app, and if we still need to throttle back more performance, we'll go ahead and throttle back on the business-critical applications, so policies 2 and 3, for example, in order to guarantee, in fact, that the resources are given to those mission-critical workloads in policy 1. So to take it to another step, the management conversation really is going to focus around vVol integration. But first off, we have several ways to manage the N5 system today. We do have a web interface, and we also have vCenter integration. So for VMware, so you can actually go in and manage the system just so you would in our web interface on the VMware side as well. Additionally, we have CLI APIs for VMware. I'm sorry, for VMware, got it on the mind, I guess, for Linux and for Windows. So if you want to do some scripting in that, you can do that as well. As you can see here, though, performance at a glance, that's the dashboard in the far left. You can see real-time throughput IOPS in latency numbers as compared to your overall capacity of the system. Down below, you can see real-time capacity utilization. On the right side, you have actionable performance statistics, so you can see real-time performance at the volume level. You can see it at the by service level, by system-wide, by controller. This is a dual active-active system, so active-active controllers are running at all times. Right, so you can see the performance on those at any given point in time as well. If you need to, what I mean by actionable is if you need to export that and make a case for adding more capacity or adding more disk capacity or flash capacity, this makes it easier to do that. You can export statistics up to 1 year in time. For policies, this is just kind of a quick view into what's going on the policy side. As I mentioned, 5 policies, mission critical. As you can see, they're categorized by mission critical, business critical, non-critical. You can see also details on policy 1. So for policy 1, those are policy thresholds are 100,000 IOPS. In this case, 100,000 IOPS. This is for one of our hybrids. So 100,000 IOPS, 750 megabyte throughput, then a maximum 5 millisecond latency. That's on an older hybrid. On the all flash arrays, you're talking maximum of 1 millisecond latency, I believe. So, and if you need to move them, you can move them directly through the system. You can take a policy and move it from one to the other real time without any downtime whatsoever. So you can move those as needed. But if you kind of, I won't say wrap it up, but this is kind of summarizing, our management for VMs. We have a couple different ways we do it without using, just generally speaking, not talking about using vVols, for example, but just generally speaking, we do enable storage silo consolidation. And what I mean by that is instead of requiring multiple arrays to address different performance needs, you can simply assign performance policies, these QoS policies, to workloads and actually have your mission, business, and non-critical workloads running on a single device, a single array, and dramatically decrease footprint, capital expenditures, operating expenditures, just much more efficiently. From a performance standpoint, right, we can do per VM QoS policies today. We've been able to do them forever at the data store level. But with VMware vVols, right, with the release of VASA 2, the VASA provider, VASA 2.0, that allows vendors, us included, to really surface some of our key features through to vCenter. So if you have, in our case, our QoS, we're now able to take those 5 policies that I was talking about earlier and surface those directly into to VMware, and they can be assigned to virtual machines, to any type of vVol. So VM level storage QoS, for example. This is just kind of a screenshot of what it looks like. But yeah, it basically takes and natively surfaces the Pivot 3 performance QoS and service levels directly through into vCenter. And it's very, very simple to do. So when you're creating your vVols, creating virtual machines, you can just assign them directly to them. And we actually had Tenasia Group do some research last year and kind of evaluate all of the storage vendors that had vVol integration, and of all of them, we actually had probably the deepest integration to provide the most benefit for customers, in the ability to take and apply those 3 tenets, core tenets of our QoS, which are setting targets, prioritizing, and placing data, assigning those all to individual VMs and to vVols. So meet those SLAs that way. So it gives you actually a more granular way to manage those virtual machines. So from a use case perspective, we see probably most of our customers, I would say 95+% of our customers are probably VMware customers, right? There are some Hyper-V mixed in there, Hyper-V exclusively, and some Citrix as well. But mostly it's VMware. But if you look at kind of where we really excel, because of the way we're designed, our data path and the quality of service we have, we really work well in mixed workload environments, right? So multiple mixed workloads, both virtualized and non-virtualized. When it comes to server virtualization, we allow a lot of our customers, if you go to our website, pivot3.com, and look at the storage systems and see some of the customer comments and case studies, many of the customers, in fact, all the customers we talk to who are recommending us to other individuals, other IT departments and other companies, are doing so because we allowed them to deliver on SLAs for an application, just bottom line. Allow them to virtualize applications which were otherwise siloed or stranded on servers for fear that they weren't going to get the performance that their end users expected. So we see things like 500% increase in transactions for a credit card company that does credit card processing. So it increased. We've seen the recompose on VDI 10 times faster. So it just allows you to put priorities where they mean the most to your company and manage it completely inside of vCenter. For VDI, commonly you'll see folks recommend to just do VDI by itself, create a separate infrastructure to deploy VDI on the storage side. But with the quality of service, you're able to assign these policies to groups of users and deal with these high volume logins and meet the critical VM SLAs for your power users, for executives, for the people who need to have access, that super low latency access. It gives it to them. It allows them to have it. We are VMware ready, the end user computer side, Citrix ready. We have partnership with Unidesk, and it's definitely, as you can see, 6 times faster boot times, 77% decrease in VDI recompose process. So it definitely enables quite a bit. So how is this is essentially how we deliver the capabilities, right? So we have the sophisticated software, but it has to be delivered on a hardware platform. As I mentioned, we have all flash and hybrid solutions. So those first 4, see there, the N5200 through the N51,000 are the hybrid arrays. They start anywhere from 2 terabytes to 10 terabytes of base flash. And that'll consist of 2 PCIe Flash cards, and they can scale. Each of them can scale in 5.2 terabyte increments, so they can go up from 7.2 to 15.6 terabytes. And then from a capacity standpoint, we've recently qualified. Capacity standpoint, the N5200, which is our lowest or smallest array, starts at 32 terabytes and goes to 128, while the other 3 hybrids go from 64 terabytes. Now we can actually go up to 384 terabytes. So we have larger boxes now. In fact, we have a 128 terabyte hybrid called the N5508, which is not on this, but we're releasing it here in just a few days. So while it says you can start at 64 terabytes raw on the hard drive side, you can actually start at 128 terabytes with a single box, up to 15 terabytes of flash in a single 3U box. As I mentioned, it is iSCSI, so 10 gig iSCSI, SFP Plus, or 10G base T. There are separate management ports in there as well, so you're not using that. For the all flash arrays, all of those have 2.6 terabytes of flash, PCIe Flash, and then the N5 1500 it starts at 15 terabytes and goes to 60 terabytes. And there are some data reduction technologies in there. We're talking raw on this, but we don't have the effective capacities on there. But we do see there is effective data reduction in there as well. Just right off the bat, probably at least 2 to 1. And then for the N5, there's another one. So these are all things that we're doing right now. We're moving at a fast pace. So we just qualified larger SSDs as well. So we have what's called the N5 6000, which starts at 60 terabytes. It scales by 60 terabyte shelves up to 3 additional shelves. So a couple of things I wanted to mention before we stop and go to questions, go to Q&A. But if you look at the bottom there, under feature sets, we do deliver an all-inclusive feature set. It's something we've done all along. So and there are features that I haven't talked about. There's data protection, snapshots, those types of things, as well as quality of service, service levels, replication, all of those types of features. They're all included, and as long as our customers stay current on their support contracts, they get any additional features at no additional cost. Also, on the support side, if during a support contract you scale capacity or performance, you don't pay support on those until you renew your support contract. So you got a 4-year support maintenance agreement, and you add additional flash in year 2, year 1, year 3, support doesn't change, which is great. I can tell you that personally from having to deal with budgeting for these types of things. You just hate to think about, you're trying to get more capacity, more performance, make these servers and storage devices perform better, and you have to think about the support for adding that as well. So it's definitely a nice feature we have. VM integration, it's all there as well. VMware integration, hardware redundancy, etc. So, I definitely encourage you to take a look at our website, pivot3.com, and explore in more detail the solutions. If it's not virtualization in particular you need help with, I would say our 2 main use cases are virtualization and SQL Server. Once again, from just being able to prioritize resources as well. So I want to thank you for your time today, and I open it up for any questions that you have. There's a Q&A button at the bottom of the screen, and if you have any questions, please don't hesitate to ask.
All right, fantastic. Let's see. First question is from David. He wants to know, what is the largest size array that Pivot 3 appliance will support?
Great question. So our largest hybrid array includes a 10.4 terabyte of PCIe Flash with 512 terabytes raw. And the largest all-flash array is 2.6 terabytes of PCIe Flash and 240 terabytes of SSD SAS Flash. And I believe, in fact, the 10.4 could be 15. Can be 15 as well. You can actually scale that to be larger as well.
All right, great. Let's see. Does the array have snapshots and replication?
Yeah, it does. That's why. Yeah, so I mentioned it towards the very end, but we do have snapshots and replication. Once again, they're included. They can be scheduled if you need them to be scheduled. But snapshot replication, you can replicate to other next-gen boxes, and we do have partnerships with Zerto and Veeam. If you decide to go, if you prefer to use host-based replication, we can definitely help you there as well.
Great. Let's see. Next question is from Katie. She wants to know, how do I decide what data goes into each QoS policy?
That's a good question. It's just because it's a concept not many people are familiar with yet. I would say if you think, this is the way I think about it at least, it depends on who you are, but if my data center went offline, which happened to me in the past, but if you lose a rack, for example, your systems go offline, which applications do you have to get online first, right? Those are your mission critical applications. Those are the applications that I would consider assigning to mission critical policies. And then from there, I would say, okay, what do I bring up second, third, fourth, fifth? That should help you really understand, to help you prioritize at least the applications that belong, that should be assigned to each policy. Hope.
Let's see. Kip wants to know, does it also speed up things like backups?
So on the backup side, yeah, I mean, so the great thing, so it's funny you ask. So there's actually a case study on our website with, I think it wasn't KMK Law, it was another, Law Bulletin was the name of the company. And they do this periodical for lawyers, I suppose. Anyhow, they were having problems with getting their backups to happen in snapshot, or the backups to happen in a reasonable time period. And what they ended up doing was they assigned the applications, the policies, to basically calm down. They assigned a low-level policy to the data that need to be backed up. And then when they did that, if it was still backing up when people came in the morning, it wouldn't impact the mission-critical apps, so that backup can continue for a little while. But yeah, I mean, that's one piece of it. The other part is that we really do well with kind of sequential, well, I should say writes. So as writes come into the system and backups are sequential, every single write that comes into the system on a next-gen box, or next-gen on a Pivot 3 box, hits PCIe Flash first. So everything, we're kind of a Flash-first architecture, so as all the data comes in, it hits Flash, or it's PCIe Flash, and then we destage it down to disk eventually, so you can get really fast writes as well, which is good. Good question.
Here's another question from David. How does it handle dedupe?
So we have a pattern matcher. Well, we have a couple different ways. So we have a feature that works very similar to kind of a little bit of dedupe, a little bit of compression. And so kind of a pattern matcher that looks for known patterns. We have a kind of a dictionary, if you will, of the patterns we typically see a lot of, especially in virtualized environments as well as databases. And we can strip those out as a write request comes in. If it's a common pattern, we'll go ahead and just update the metadata table. And then that'll be stored in memory. And then as a read comes in, we can just go ahead and read request comes in, we can just serve that out of RAM CPU. Another benefit of that, in fact, is that when this is something that many array vendors do, but we do that kind of large striping. So coalescing multiple writes, small writes together to create one large stripe down to the SSD, or to disk, which extends the life of the SSD, which is great as well. But that's typically how we do the data reduction.
Great. Let's see. Can I change a volume to mission critical for only a few hours a day?
Yes. Yeah, we can. You can. Typically, it used to be done scripted. You could script it. I believe in the next version of our software that's coming out in a month or two, you'll be able to actually schedule QoS for particular workloads. So say if you had to hammer on a database once a month for reporting and you didn't want it to impact other workloads, you could switch that, for a couple days a month. Or you can just do it manually as well. It's pretty easy. But yeah, you can.
All right, let's see. What is the disk type and RAID within the array?
So the disk types we use, we're active controllers. So we get dual active controllers, which means we have to use dual ported drives. And each of the systems has 16 drives, and then we separate those into two 8-drive RAID 6 sets. So dual ported SAS. So we're not using SATA. We use dual ported SAS for both the SSD and the disk drives themselves. And of course, we have the PCIe Flash, and that's a little different in that part of that card is reserved for writes only, so it's protected for writes only to come into the system. So as a write comes in, we mirror it to the other card, so it's protected and highly available. And then we can destage it, and the other part of the majority of it, in fact, is used for read cache, and that's not protected. We don't need to protect that. So that's how that works. And then one thing I didn't mention that I should mention is with those service levels, because we are dual controller, instead of using active passive where you only use half your controller all the time, and if it fails you just bring the other one comes up and you're still running. We run active all the time, but if you lose a controller, if a controller goes off for any reason, we enforce those service levels, right, that the QoS settings assign. And even with one controller offline, we can guarantee that the mission critical policy, that highest level policy, will be enforced. And so that's really important to mention as well, because it's one thing to be available. It's another thing to be able to perform during a failure event, during a degraded mode operation, and this is able to do that.
Great. Let's see. Here's a good question from Ryan. How does the HCI have the same QoS features?
So today, so I don't want to spill the beans too much, but we're in the process right now of creating new policies for the HCI system. So let me step back. Our hyperconverged systems from Pivot 3, they're unique in a couple different ways, but one of them is that they're not a silo. So it's not that you don't have to just assign storage within the HCI cluster to a VM within the HCI cluster. You can actually attach storage to external storage to via iSCSI, for example, to a VM in there. So right now you can assign a VM within the HCI cluster. You can assign a policy to it, whether it's mission critical, non-critical, and later on this year we're going to have policies that are specific to the types of workloads you see in an HCI system, specifically designed for our own HCI. And then over time you'll begin to see much more convergence between the HCI and the flash storage systems. I really can't go into too much more than that at this point, but that's the future of this year. That's what it's kind of looking like. So right now it's using existing policies. Later this year it's using their own policies off of this system, and then over time you're going to see those policies move into the HCI in and of itself, minus the requirement of having the N5 system.
All right, fantastic. Let's see. Okay, so we're running up close to the time you wanted to stop, but we still have quite a few questions. So guys, if we didn't get to your questions, we will be able to answer those offline. Thank you all so much for this presentation. Do you have any final words for our audience, George?
No, yeah, sure. So the key takeaway is, you got a lot of decisions out there. Every vendor and their mom has some way to accelerate your data. Think beyond simply the hardware associated with it, because SSD in and of itself, flash in and of itself, goes fast. Being able to prioritize that performance is much more valuable and enabling, because at the end of the day, it's not about flash, it's about ensuring that your end users are satisfied, and you meet those SLAs. So keep that in mind as you consider, multiple flash arrays. And if you need any more information, definitely you can reach us at our website, pivot3.com.
All right, fantastic presentation. Thank you so much, George. So I do want to remind everyone that we will be following up with you offline with any additional questions you might have had. And if you had to step out or miss any part of this presentation, you'll be receiving an email in just a few days with a link to view the webinar on demand. Special thanks to Pivot 3 for creating today's content and sponsoring this great event. And thanks to each and every one of you for tuning in today. We hope to see you back soon for another SpiceWorks Partner webinar. Until then, stay safe and keep it spicy.